A long time ago, we discovered ways of finding our way using the stars and the sun. But then it was realized that the Earth had a magnetic field that could be used to help us find our direction using a compass. Now, old compasses were quite basic and couldn't show directions accurately, but here is a modern compass. Oh no, don't get it mixed up with a pair of compasses, which are used to draw circles. The compass can be used with a map to measure directions, and then the magnetic needle can help us realize those directions in real life and find our way to where we want to go. So, let's start off with the basics. There are some main compass directions. You probably know these, that north is usually at the top of the map, and opposite north is the southerly direction, or south. And then we have to the right and the left, we have west to the left and east to the right. W and E for west and east spells the word we. If you had them the wrong way round, it would spell the word ew, which is not very good. Right, now we can further divide up the directions to make them more accurate into 360 degrees, starting with north as 0, east is 90, south is 180 degrees, west is 270, and then when we get back to north again, it's 360. So north could be 0 or 360 degrees. It's a good idea to be able to make a rough estimate of what a bearing is in degrees. So that's about, I would say, 40 degrees? If we go round further than east, which is 90, that was about 110. This is roughly 200 degrees, would you say? And if we're coming up back towards north again, maybe this is 310, 320, something like that. So let us recap. A bearing is a measurement of direction between 2 points. It is given as the angle measured clockwise from north. And bearings are normally given as 3 digits. So can you see here that the bearings that are less than 100 contain leading zeros to bring them up to the 3 digits. And on maps, if north is not at the top, you'll probably get a compass rose showing you which direction is which. And now we move on to level 2 of the online exercise, where you have to measure some bearings with a protractor that you can drag on the screen using your mouse. If you use the shift key on the keyboard, the protractor will rotate. And if you don't have a keyboard, there's a little checkbox higher up the page that you can check for rotating the protractor. So remember that we measure from north as 0. So you have to line up the protractor so that the 0 on one of the scales is where the north is, and have to make sure that the center of the protractor is at the sort of the point of the angle. And then you measure and type in, remembering the leading 0, the 3-figure bearing then in this case is 057 degrees. Now at the bottom of the page there's a check button, and you can click that, and you should do that frequently as you're going through this exercise to make sure that you're answering the questions correctly. Okay then, so let's now drag the protractor onto question number 2. Line up the center, make sure the 0 is over the north. You'll see there are 2 scales on the protractor. There's the blue scale and the black scale on mine. You choose the scale that starts at 0 at north, so that's the black one in this case. And then look around to the arm of the angle, measure off the angle, and type it in. Make sure you're using 3 figures. So basically that's all there is to it. You put the protractor, measure, and type in your answer. Oh, unless the bearing is greater than 180 because my protractor has only got 180 degrees. So my little trick here is what I'm going to do is rotate the protractor and actually measure the part of the angle or the angle that isn't the bearing. So I'm going to start from north and measure the angle anti-clockwise and then subtract that from a full turn or 360 to work out what the correct bearing is. So here we go. I'm going to measure, in this case, using the blue scale because that's the one that starts with 0 up at north. Measure that angle, and that's about 128. So I'll subtract that from 360 and get 232 degrees. So as you go through the exercise, it's a good idea to estimate what the bearing is just to check that your measurement is correct. And if you make a mistake, what should you do? Well, if you do make a mistake and you click the check button and you see a little red cross appear, you can work on it again, just change your answer, click the check button again until you get it right. So can you see what I've done wrong in this case? I've used the right scale. I've used the scale that started at 0, the black scale, and I've got 85 degrees. But remember, bearings should have 3 figures. So I need to insert that leading 0 right there before I can collect my trophy. Let's assume a plane is flying on a bearing of 065 degrees from Heathwick to Narita airports. In order to prepare for the return trip, the plane is turned round through 180 degrees. So the bearing of the return trip is altogether 245 degrees. This is known as a back bearing, and it's easy to find. You add 180 to the original bearing, unless the original bearing is greater than 180 degrees. So in this case, where the bearing is roughly 300 degrees, if you added on 180, you'd get a sum greater than 360. So in this case, we'll assume a left half turn and subtract 180 degrees from 300 to get a back bearing of 120 degrees. When you get to level 4 of the online exercise, you're required to draw a scale drawing. So in this case, the first thing you do is you make a rough sketch of the situation described in the question. And the rough sketch will help you when you're drawing your accurate drawing to put your first dot in the right place so that your diagram doesn't go off the edge of the page. So in this case, I can see that E is 6 kilometers on a bearing of 130 degrees from D, and F is 12 kilometers due north of F. So here's my rough drawing of the situation. I can see that I have to find the 3-figure bearing of F from D. So it's that little angle there that I require as my bearing. And now I go to my graph paper, knowing what the full diagram looks like. I can put my starting position, D, in a sensible place so that my diagram doesn't go off the edge of the page. I'm using graph paper because it just makes it slightly easier to get your north lines drawn so that they are pointing what appears to be north. So I'm starting off now with this bearing of 130 degrees. I'm measuring 130 degrees from D with a protractor, and then I draw a line, and I'm using 1 centimeter represents 1 kilometer. So I'm making this a 6 centimeter line to represent the 6 kilometers in the question. Right, now I've got the point E. I can draw a line that's going due north. Don't need the protractor for that. draw a 12 kilometre or 12 centimetre scale drawing of that line to give me point F, which is right up there. And now the angle I need is the angle at the point D, which is measured from north in a clockwise direction. So it's this angle here, where I get my protractor, put the 0 pointing to the north, measure the angle as accurate as I can, and there is a bit of leeway here. You're allowed to be 1 or 2 degrees out. Don't forget the leading 0, because this angle is less than 100. So there we have it, scale drawing to solve these sorts of questions. And finally, level 5 of the online exercise using trigonometry to answer the questions. So I'm going to draw myself a right angle triangle to represent this situation of a plane going 8 kilometers east and then 7 kilometers north. And I've got to find the bearing of its new position from its original position. So I'm using trigonometry as you would do. In this case it's going to be the tan ratio, and it gives me the angle which I've rounded to the nearest whole number. But of course that's not the bearing. The bearing is measured from north going clockwise. So I subtract the 41 from the 90 and get the answer 49. So that's how you would do that sort of question using trigonometry. You may also have to use your angle theorems, using alternate angles, corresponding angles, angles around a point, and each of the north lines, of course, are parallel. So that gives you the parallel lines to solve those questions. Okay, so have a go at the online exercise, and there are plenty more activities that you can do on the Transom website, so do have a go at those. See you next time. Bye.
You can find Transom Mathematics at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.